I don't see my screen anymore.
Okay, we're about to go live.
Okay.
Hello again, everyone. So, I'd now like to introduce Alexandre Demoulin, who is the Senior Industrial Engineer. Is the Sales and International Business Development Director at TSI. Alexandre is a Senior Industrial Engineer with 15 plus years of technical sales experience in instrumentation, engineering, and services, and he's going to talk to us about noise and vibration management in vessels from initial design to sea trials.
Thank
Over
you
to
very
you,
much.
Alexandre.
Thank you very much, Tim, and good day to everyone. And welcome to this webinar focusing on the ship noise and vibration. So reducing noise and vibration from ships has originally been linked to mechanical failures and maintenance optimization. However, over the last 20 years, it has become an increased concern for the passengers, the crews, and surroundings of the ship. Today, it appears as a key holistic objective linked to the comfort and operability, but as well as to the greening of the shipping. Indeed, noise and vibration emissions still disturb passengers on board and affect the crew operability, but also contaminates the inhabited coastal and harbor areas. Less obvious for us who live above the surface, ship underwater radiated noise, usually called URN, due to continuous and increasing traffic, is also recognized to have adverse effects on the marine wildlife. So we thought it would be useful for you to be informed about these issues and make you aware of TSI-related solutions offered to their customers. I am Alexandre Desmoulins, Head of Sales and International Business Development at TSI, Técnicas y Servicios de Ingeniería. We're based in Madrid, Spain. So, presentation will be split into 4 parts with the objective of generating awareness about how noise and vibration can influence the design and condition future comfort and performance of a ship. So we'll first briefly clarify the context and regulations, then share the main points of noise and vibration control, and finally illustrate our presentation with a recent case study. In this section, we'll give you a few basics on noise and vibrations of ship and then give you an overview on what is driving noise and vibration reduction that is all current and upcoming regulation. So, to start with, a few basic definitions of noise and vibration. The IMO says the noise corresponds to all sounds which can result in hearing impairment or which can be harmful to health or be otherwise dangerous or disruptive. What's important to note here is that noise is unwanted, noise can be disruptive and dangerous for the health. Noise can also propagate in both air and water from a source such as loudspeaker, engine, etc., to a receptor, our ears or microphones. So what are vibrations? So vibrations is a mechanical phenomenon whereby oscillations occur about an equilibrium point. Different systems can be subject to vibrations. A simple system, as you can see here, can be subject is mass spring system as shown. However, there are much more complex systems like a ship. As you may know, there are several sources on board a vessel which are mostly linked with the propulsion, that is propeller, engines, exhausts, but also on systems that condition the life aboard, such as chillers or HVAC. As mentioned before, noise can propagate through both air and water. Therefore, while looking at noise and vibration, we may face different challenges. First, The most well-known is the noise on board in accommodations and workspaces. Second is the noise radiated in the water. And finally, what we call airborne noise is the noise that is radiated outside the vessels, for example, in the harbors. While looking at noise and vibrations, we have to look at the frequency domains. Here you can see that the generated noise and vibration cover a very wide range of frequencies from 0.1 Hertz up to 50 kilohertz. At lower frequencies, we can find the global and the local vibrations up to 100 Hertz in that case, and then at higher frequencies appear onboard, airborne, or underwater radiated noise. So why showing this? Well, basically to show that noise and vibration are tightly linked and that there is no clear boundary between the two phenomena. Also, so that you can understand that the tools to handle noise and vibration will need to be different to address all this wide frequency range, and that this will require a specific expertise. Now let's explain why we should take care of noise and vibration on ships. Of course, there are regulations to drive noise and vibration rate reduction, but what is at stake for noise and vibration on ships? Well, first, all of the crews, as I said, as I said before, noise can cause air impairment, but one has to know that vibrations can be harmful on the whole body or on hands. If we go further than health, one of the stakes is the comfort of the passengers, but also of the crew. Today, more and more ship owners consider comfort as a high priority. Then, another stake today is the effect of noise on marine fauna. There are several studies made currently in progress that are showing the impact of underwater noise on marine life. Owners who want to demonstrate their environmental awareness are showing more and more interest on this topic. And last but not least, asset integrity is to be taken into consideration here, mainly because of vibrations. In the past, we have witnessed several vessels being subject to structural cracks or suffering from machinery damages, and that is what was due to important vibration. So these four aspects are on top of that. The regulations are driving the noise and vibration control of ships. Let's talk now briefly about the applicable regulation and start with the regulation dealing with noise. There are four entities or bodies which are setting regulations driving noise reduction of ships. You will see some of them are mandatory, others are voluntary. First of all, the International Maritime Organization, IMO, released in 2012 the resolution MSC 337 of 91 called Code on Noise Levels on Board Ships. Their objective is to limit noise levels and reduce seafarers' exposure to noise. In this case, the mandatory aspects are noise level limits in accommodations and working space, and sound insulation in accommodation spaces. All these criteria are measured on board before the delivery, generally during the sea trials. With these premises, class societies have developed their own rules related to noise and vibration, which are voluntary, and in vessel specifications, owners are generally referring to these additional class notations. Some flags rely on IMO requirements, and others, like France and Spain, are defining noise limits in terms of noise exposure for the crew members. Finally, more and more local incentives also apply those rules to the underwater radiated noise. In a similar way, let's do the same exercise for vibrations. it has first to be mentioned that IMO hasn't defined any requirement for onboard vibrations. However, and as for noise, some flags are requiring vibration exposure assessment for workers. And in this context, classification societies are playing a key role here to define vibration requirements. Here again, owners are generally referring to these additional class notation in their vessel specifications. Before moving to the next section of the webinar, it is important to say a few words about the upcoming regulation, and they mainly concern underwater radiated noise. What may drive future regulations are the current projects. TSI is currently involved in projects funded by the European Commission, where one of the outcomes will be to develop methodologic tools to policymakers. And I invite you to access Piaquo or Saturn websites on the internet to know more about those very interesting projects. 2023 appears to be a cornerstone for URN at IMO. Thanks to Canada efforts supported by many members states, the 2014 URN guidelines will be revised. In this section, we will describe how noise and vibration will be controlled in a vessel. Okay, let's first define what produces these phenomena and what types of noise and vibrations to consider and control. The main source and vibration of noise and vibrations in a vessel are always the same, but they depend on the vessel mission and, of course, on its onboard machinery and propulsion systems. Our approach is based on an evaluation of the vessel general arrangement to locate the main noise and vibration sources for subsequent analysis, such as propulsion systems, auxiliary machines of the engine room, gearbox, etc. Okay, each source emits different types of noise and severity. There are three main types of noise within a vessel, and their nature depends on the propagation path to be considered. First, airborne noise. It's associated with the mid and high frequency noise transmitted through the air from the different onboard machinery to the whole local and surrounding spaces. Second, the first structure-borne noise is related to structural vibration transmitted from onboard machinery through connections and foundations, propagating this type of low-frequency noise all over the vessel structure. And last but not least, the second structure-borne noise. That's the one that is initially transmitted by air as airborne noise and at the same time excites the structure elements, producing vibrations that are re-radiated as airborne noise in the surrounding spaces. So once the noise and vibration sources, types of noise and transmission path are known, the available control technique will allow us to focus on the three main subsequent strategies. First, attack the noise sources itself, which is also the less expensive strategy and the most efficient one, especially if it is considered since the modeling stage of the vessel and not only during the shipbuilding. Secondly, we can also attack the path transmission. This strategy has to be considered after evaluating potential actions to be taken and the sources, at the sources, and also more, and this is also a more expensive operation than the previous one during the shipbuilding. And finally, attack the receiver spaces themselves. This is the last option for controlling the noise and vibration. That is interesting when previous actions were not sufficient and were not possible to be carried out. This one is recommended to mitigate noise and vibration effects in specific spaces that do not comply with the customer requirements. Now the question now to be answered is, what could we propose to our customers, to our clients, to address noise and vibration issues? We will then present the service offer which have developed TSI over the last 40 years. And first, a slide to list. We have a slide to list all the services that we are able to propose from early stage of a project upon up to service vessel, in-service vessel. This includes all studies at design, building follow-up, measurement during sea trials, factory acceptance tests, and in particular troubleshooting for in-service vessels. From now, we will focus on services that can be proposed for new building projects. So thanks to the years of experience acquired and trust from our customers, TSI has developed 3 standard offers to answer customers' needs, going from a basic study to a full comprehensive support. The basic study will consist in a preliminary analysis of arrangement. It is a qualitative study and to be understood as opposite of a quantitative study. The advanced study offer will include quantitative analysis with detailed noise and vibration predictions. The budget will also depend on type of vessel and the scope of supply. Finally, comprehensive study will include all support during the project, including qualitative, quantitative studies during building and follow-up, and finally, sea trials. So when such studies can be proposed, basically before construction, that is during specification or bidding stage, during basic project stage, or at design stage. This can be proposed to all types of vessels with low noise and vibration requirements, especially for comfort, noise and vibration 3, okay, or IMO MSC 357 conformity. What are the objectives of this study? To give preliminary solutions and recommendations, to avoid any onboard noise and vibration issues at later stage. On this slide, there is an example of recommendation that could be given regarding noise. We identify from the general arrangement where the sensitive areas are located. For example, here close to the casing or the thrusters, and we recommend suitable insulation. Here's an example of insulation recommended above both thrusters. So when such studies can be proposed, we're talking here about the advanced study. This can be proposed to all types of vessels with more stringent noise and vibration requirements, such as comfort, noise and vibration 2 or 1. The main objectives of these studies are quantify noise and vibration levels of the ship, provide solutions in case of identifying these issues, and generate numerical tests, to ensure their efficiency at the end. Content of the studies. Basically, what are the deliverables? Vibration predictions using a 3D finite element model of the vessel. Here you have the methodology that is used for such numerical simulation. Okay. If a non-compliance was identified, structural modifications are proposed to the customer and tested numerically to finally ensure that the design will comply with the requirements. And finally, the comprehensive study covers the support during the whole study, the whole project, from very basic studies until the sea trials. And finally, just to highlight a very interesting point that TSI can offer sea trials and is certified with the main class societies in the world. Okay. Just for you to highlight and to basically for you to figure out with an example. We have a case study, recent case study here that we performed with the customer. We delivered. It's a quite unusual ship because we're talking about a dredger here owned by Van Hoort. And this project was delivered in March 2020. The scope of the work was focused on the second standard offer, the previous section. So to fulfill basically the demanding requirement of Conf VIB1 and Conf Noise 1. Okay. So even if this type of vessel has very harsh of operating condition, it's actually possible to reach good results from a noise and vibration standpoint. Okay. So according to the scope of work, 2 predictions were performed, vibration and noise, and these results were compared to the final measurements. Okay, here. So we start with the vibration predictions with finite element modeling. Okay, for this prediction, we first made an exhaustive study of the ship structural drawings themselves, and then all the relevant areas, vibration, where we get vibration sources were included, and basically we generated dynamic loads to obtain the model and forced responses of the vessel to understand its structure dynamic behavior. In this case, the ship was completely modeled, as you can see, by finite elements, and the main and only source considered was the propeller. Main engines and other excitation sources regarding the machinery were not considered because they were mounted on elastic foundations. Model analysis allows to obtain the global and local natural frequencies and their mode shapes, which can be analyzed for assessing the hull girder structural behavior. That assessment consists of using a Campbell diagram to evaluate the potential resonance risks of the ship's main modes, including those of the hull girder and others of relevance, with respect to the critical speed of the propeller given by the blade passing frequency. In the coincidence between the natural frequency and the critical speed occurs within a range close to a defined safety margin around the nominal propeller speed, this resonance risk is considered to be high. So resonances must be avoided within that safety margin that considers the speeds at which the ship normally operates, and at the same time the uncertainties of the numerical model. Regarding noise prediction, we'll consider in the study all operation profiles of interest with the idea of fulfilling any class notation of specification. Here, this prediction is performed using an SEA model and considering the electric balance of the ship, specifying the operational regime of each considered source and obtaining its influence on the different spaces of interest. So this model, as you can see, allows us to switch on and off the different sources according to the specific operational profile, therefore accelerating the efficiency of the calculation process. In this last slide, we show the comparison between the simulation and actual measurements made on board, as well as a comparison with respect to the noise levels of the requirements to comply with the class notation in all the ship spaces during the sailing conditions. As you can see here, all measurement noise levels met the limit except from just only one, the cabin crew, the crew cabin. Sorry. So regarding the discrepancies between prediction and measurement, as it was mentioned before, numerical models provide accurate estimation of physical phenomena, and it is the same in this case. These slight discrepancies are mainly produced by the following main reasons. For example, insulation material used during the construction, insulation installation errors, for example, or non-accurate sound pressure levels provided by the equipment manufacturers. For sure, this last circumstances is a critical point that must be addressed in the specification documents to force manufacturers to provide accurate noise data, which is very essential for this kind of predictions. Well, I hope that you found in this last section interesting, and in any case, the intention was to show the outstanding potential of these solutions to control noise and vibrations with a real case. That was a success from a standpoint of the ship owner also, the certification body and provider of the prediction calculation. So just to wrap up this presentation, you now have in mind the key drivers to consider noise and vibration reduction. You are better acquainted with the noise and vibration control basics, and you are empowered with standard offers, for which, of course, we remain at your disposal for any support. So I now leave the floor to Tim and to your questions.
Tremendous. Thank you very much, Alexandre. That was fascinating. I've just got one quick follow-up. The modeling and the numerical analysis you're doing, is that good enough to satisfy the class and notation requirements on its own, or do we still need onboard measurements to verify it?
Well, we actually need onboard measurements, and onboard measurements are compulsory to meet the class notation. However, numerical prediction is really the first step to ensure good design practices and to reach minimum noise and vibration levels. This guarantees future savings also during shipbuilding on the insulation material and the weight control.
Got it. Okay. We've got a question from Charles, actually. He's asking, what software are you using for the analysis? And are you building a vibro-aero-acoustic solution?
Okay. To be honest, I am not aware of the name of the software itself. But as I mentioned before, we normally use more finite elements for the vibration studies, and a different software for the noise and the noise prediction. I can maybe, if I get the more detailed question outside the separately, I can answer in more details.
Tremendous. Thanks. Okay. Alexandre, perhaps Charles, he could email you more detail, or you could email Charles.
Yeah, Charles can contact me direct on the stand. Okay.
No Thank you. And if anyone else has got any follow-ups, then please do fire them to Alexandre using the platform. I think we're out of time now. That brings us to the end. We've got a break now until 11:10. The break, obviously, an opportunity to go and get some coffee. So please do visit and talk with the exhibitors and other attendees through the messaging and one-to-one video networking facilities on the platform. And we'll see you again at 11:10. Alexandre, thank you very much once again.
Thank you very much for your attendance, and I'm at your available for any further question on this platform. Thank you very much.
Great.
Have a good day.
Thanks, everyone.
Take care. Thanks, team. Goodbye.
Bye.